Right, here's another video which is designed to maximise the number of points you can score in an exam in a quick way. Perfect if you've got a test coming up and you just want to quickly blast through a quick reminder. Right, so very quickly, if we're going to talk about distance time graphs, we just need to remember what speed is first. So remember, speed equals distance divided by time. The main things I'm going to be going over here that I know come up in an exam is that you've very often get asked for some typical speeds for some moving objects. You get asked, do you know how to plot the speed of an object on a distance time graph? And you've got to know how to calculate the speed from the gradient of a distance time graph to access higher marks. So what are typical speeds for some moving objects? Easy. You get 1 mark in an exam for knowing how fast you walk, how fast you jog, run and cycle. So there's some values there for you. How can we plot the speed of an object on a distance time graph? So basically, if you are getting the gradient of a distance time graph, distance is on the y-axis, time's on the x-axis. The gradient is always y divided by x, which will be distance divided by time, which tells you the speed. So if you see a straight, steady line, that means a steady speed. Okay, constant speed. Right, for 3 marks in an exam, can you explain what object A is doing? Right, well, it's a very steep line, so we know it's moving fast for 1 mark. But how do you get the 3 marks? Well, basically say it's covered a large distance and it did it in a short amount of time. Okay, so if you're covering a large distance in a short time, it means you're moving fast. That's how you get your 3 marks. What about this thing then? Object B, explain that. Well, using a similar language, it's only covered a short distance and it's took a long time, so it's moving slower. All right, small distance, long time. 1, 2, 3 marks. Bob's your uncle. Right, what about this flat part? Well, the object's moved forwards quite quick, but then it's got to say 10 meters and it's not moving anymore. So the time's still ticking away and it's still, so a horizontal line means that the object has stopped moving. What about if the line starts to come back down? Well, it might mean that they've travelled, say, 10 metres forwards and then they're coming backwards. Notice how they're travelling backwards a lot slower than what they travelled forwards. So it's coming back to its starting position. Right, so basically, imagine that you're on a bike, all right, and that the graph is a hill, right? The slope is a hill and you're rolling down on your bike. The steeper the slope, the faster you'll roll, wouldn't you? And this slope here is not very steep, so you would just roll down there slowly. So that's a way to think about it. And if your bike was on a completely flat slope and you weren't allowed to pedal, you'd just fall off sideways and face plant. So if the slope's flat, it means your speed's 0. So these are the main parts then. On a distance time graph, tell the examiner that you know the gradient tells us the speed. Tell the examiner the steeper the gradient, the faster the speed, or the flatter the gradient, the slower the speed. And basically if the line goes flat, completely flat, then it's stopped. So let's apply some information that we know. Now Einstein said that imagination's more important than knowledge, but we now know that you cannot have an imagination or be a problem solver without first gaining some background knowledge, because it's only when you bring all your background knowledge together that you're able to solve problems using your imagination. Right, so use the background knowledge that I've just taught you to solve this next challenge. What's happening on this graph? Now, I know you may think, well, I haven't taught you about a curved graph. Right, well, that's the whole point, isn't it? What we know, right, is look at the graph. Is it getting steeper and steeper or flatter and flatter? You'll be able to work out what's going on. So the graph is getting steeper and steeper, and we know If the curved line's getting steeper, that shows the object's getting faster and faster, which basically means the object's accelerating or speeding up. Right, same rules apply. What's happening here? All right, once again, the hint is look at the slope. Is it getting steeper and steeper or flatter and flatter? Well, you can see that the slope is getting flatter and flatter until it becomes completely flat. So that basically shows us that the object's getting slower, or it's decelerating, to put it a different way. Right, put your knowledge together. Sometimes in an exam it'll say explain what the parts of the graph's doing. So part A, it's a constant speed because it's a constant slope. It's not very fast either. B is completely stopped. It's stationary because it's completely flat. Part C, you can see the graph is getting steeper, which means it's accelerating or speeding up. Here you can see the slope is getting flatter, so that means it's slowing down. And here the object's moving back to the beginning, and it's actually doing it quite fast because it's steep. Right, so have a go of these. What's happening on each of the graphs? So here, constant speed because it's a constant slope. Here, constant speed but it's faster. Constant slope, that's steeper. This one is constant speed again, but it's slower. This object here is not moving. This object's going back from where it started. And this object, because the slope's getting steeper and steeper, that means it's accelerating. It's getting faster and faster. Right, harder stuff. Know how to calculate speed from the gradient of a distance time graph. So it's sometimes difficult to tell what the gradient's actually doing. So what the examiner will do is they'll just make straight lines rather than all of these curves. Right, so basically, what is the speed of the object between points B and C? Right, well, we need to know the time between points B and C, and we need to know the distance between B and C. So you can see the time started at 3, finished at 6, so that's 3 seconds. And the distance started at 10 and finished at 70, so that was a total of 60 meters. So if it's traveled 60 meters in 3 seconds, do speed equals distance over time, which is 60 over 3, which comes out as 20 meters per second. Now, if you were to calculate the object speed between points A and D, will the answer be the same? Well, no, it won't, because between A and D, you've got that slope there. Does that slope there look the same as that slope there? Not at all. What you'd be working out from A to D is the average speed, because you're doing the total distance divided by the total time. So total distance was 70 meters, total time was 9 seconds, 70 over 9, 7.8. So that is different to that. All right, so this here is your average speed, whereas this is the instantaneous speed. So the instantaneous speed is basically the speed at a given instant. So between B and C, so for a particular part of the journey, rather than the whole journey, which is the average speed. Right, here's your opportunity to practice what I've just told you. Pause the video and have a go at that. And here's the answers. And here's some more questions to try. Pause the video to give them a go. And here's the answers. Pause the video if you want to look at them. Right, sometimes they ask you to plot a distance time graph. So I just get my students to walk 30 metres, jog 30 metres, sprint 30 metres, chuck a tennis ball 30 metres and kick a footy 30 metres. Your distance is 30 metres, so you got to go up to 30 metres for the maximum, and the time is whatever it is. And basically by the time you've plotted them on the graph, it should take longer to walk 30 metres than it does to jog. And you can see the graph is getting steeper and steeper as things are taking less time to travel the same distance, like the tennis ball's the steepest, because it was the fastest. You'll get marks for correct plots in an exam, for doing a line of best fit on an exam. Make sure you always get your headings and your units on both axes for a mark, and make sure you've got a nice large scale. If they give you some graph paper, you've got to use at least half of the width of the paper and half of the height. Otherwise, you could lose a mark for your scale. And here's a little summary. Pause the video if you want to have a look at it. And here's the answers. Pause the video if you want to read over it. So I've just covered 11 marks worth of content at least. So if distance time graph does come up on the exam, you should do well. So work hard and be nice until the next time I see you, and keep working on your resourcefulness and your initiative, which is your willingness to find things out for yourself by using videos like this. Bye bye for now.